Okay, so you've been told to take the derivative of this equation here, but your problem is you have a y squared and it's on the right of the equation. Now, you could theoretically bring the y that side, bring the 5 here, and square root it, and then take the derivative of the plus or minus square root, and that's going to be super long. Or you could do it this way. So I must say that every time you get something that has to do with implicit differentiation, you get a question that would say find dy over dx. And this is the other notation I showed you other than y prime or f prime of x. Now this is not a function anyway, so you shouldn't be worried about f prime of x. So dy over dx is the notation which will be used for most of these questions. I would say if you were to solve it, it's much easier to understand this notation. So when you do something like this, right, it's important to understand that dy over dx means derivative of y with respect to x. So you're going to do the same on both sides. You're going to take the derivative with respect to x. So d, you don't get y yet, over dx. D over dx means derivative. And parentheses x squared plus y squared. And now you solve for the derivative on both sides. The derivative of 5 is 0. We know that. Now, here, the derivative of x squared we know is 2x. Plus, you would do the same for y. You take the 2, multiply here, and then you subtract 1 from the exponent. 2y, but then this would become dy over dx. You add that small bit over there, and that's your dy over dx and how it comes up. Now, this 2x goes here and you divide by 2y, so negative 2x over 2y equals dy over dx. And that's how you find dy over dx. Okay, so we're here, and this is probably one of the harder examples that I'm going to show you with this, but this incorporates multiple variables, as you can see, with z being there too, and we have to find dy over dx. Okay, now, we're also given dz over dx, which we'll come to once we take the derivative. But before we do that, we need to understand, when we take the derivative, what exactly is going to happen. Now, if we take the derivative of this immediately, we have to do a complex product rule with these two, and x and y squared over x squared. And it's going to get really messy if we do that. So what I'm going to do is multiply this x with the two terms, and then simplify it a bit. That way I can take the derivative. So when I simplify, I get x to the fourth, y to the third, plus y squared over x. Now I take the derivative of both sides, so I'm going to get d over dx, parentheses, and then dz over dx. Now honestly, if your teacher asks you to make these two separate steps, you should. I'm just doing this because this takes a lot of space, and I'm explaining it to you guys anyway so you can understand it. But yeah. So, moving on. We take the derivative. But notice how the first term is a product rule. So the x to the fourth would be our first term, the y to the third would be the second term. So, product rule would be the derivative of the first times the second plus the derivative of the second dy over dx times the first x to the fourth. Okay, now we do quotient rule here. Okay, quotient rule, let's go. When we do quotient rule, derivative of the top, 2y dy over dx, it's x times the bottom, minus derivative of the bottom, that would be just dx over dx. I just want to show you what happens when you do that, because dx over dx is technically the same as writing 1, so this will be 1 times y squared. Divide the whole thing by x squared equals 3, because dz over dx is 3. You can leave it like this if you can, but technically you're not supposed to, because you're trying to find dy over dx. Now we must separate dy over dx. Okay, to do this, I'm going to first see what I can bring to the right. Okay, I'm going to get the 4x to the third, y to the third, that way. So 3y squared dy over dx, x to the fourth plus 2y dy over dx times x minus y squared over x squared. Alright, so equals 3 minus 4 x to the third, y to the third. Okay, so we're here, and now my two dy over dx terms are here, but one has a fraction, so I must get rid of that. So what I'm going to do is multiply both sides by x squared to get rid of the fraction once and for all. So I'm left with 3y squared x to the sixth dy over dx plus 2y dy over dx. I'm gonna say 2yx dy over dx minus y squared equals 3. Now we have to multiply by x squared, right? 3x squared minus 4 x to the fifth y to the third. And if you see this now, we have simplified this a lot. So moving on, what we're going to do is we're going to subtract this y squared, and then eventually what will happen is that we'll have dy over dx on both sides, so we can take that out and put these two in the parentheses, and it becomes a factor which we can divide. So let me show you that. 3y squared x to the sixth dy over dx plus 2yx dy over dx equals 3x squared minus 4x to the fifth y to the third plus y squared, just to make sure the signs are right. Now, these dy over dx could be pulled out like this. 3y squared x to the sixth plus 2yx times dy over dx equals all this on the right and now we just divide this over this, and dy over dx ultimately is 3x squared minus 4x to the fifth y to the third plus y squared, all divided by 3y to the second x to the sixth plus 2yx. And that's all you need to do. You just have to take it step by step to get an answer like this. Don't be overwhelmed by these questions because they are all solvable. I promise you, once you do one step, you automatically get clarity on the next steps going forward.